Hey guys, today we're going to talk about basic factoring. One of our factoring methods whenever we're working with polynomials, specifically trinomials. Now, I want to remind everybody in the beginning of the video, we're working with polynomials in a standard form of ax squared plus bx plus c. We're going to be referencing a, b, and c as names for some of our terms or our numbers as we're working on the factoring, and this is where we are getting them. Additionally, I want to establish the criteria for basic factoring. So, in basic factoring, we need to be working with a trinomial that is x squared, x, and a constant. Now, it of course could be y squared, y, and a constant. Variables, you know, as long as they're all the same, if there's a squared one, an individual one, and then a number without a variable or a constant, we're good. So it must be a trinomial in this format. Secondly, the a value must be 1, or a equals 1. I don't really know why I wrote value there, but you get the idea. So if a is greater than 1, can't do this. If it is not a trinomial with a squared variable and a non-squared variable or a variable to the first and a constant, can't do it. Now let's get into how we work on this. Let's start with x squared plus, I don't know, let's say 8x plus 12. So here's how it goes. The first step to basic factoring is to create two binomials. As you know, whenever we're factoring polynomials, specifically trinomials, we end up creating two binomial parts or factors to that polynomial. We're trying to create two binomials that when multiplied are equivalent. Now both of these are going to begin with an x. Since our a value equals 1, that would be the coefficient in front of the x squared. We don't see 1 there, so it's the invisible 1 idea. Both of these are going to start with x. Now what we need to do is we need to figure out what numbers go with the x in these binomials. To figure that out, we have a really important sentence that we have to kind of solve. That sentence is we need factors of c that add to equal b. So like I said at the beginning of the video, we're going to be referring to b and c and a quite a lot whenever we factor. What is our c value here? 12, right? It's our constant at the end of the polynomial. So factors of 12 that add to equal b. What's b in this polynomial? 8. So we need factors of 12, and those two factors need to add to equal 8. This is kind of a diagram that I personally like to use, because if I plug in my two numbers here, I can see, okay, both of them would multiply or would be factors of 12, and both of them would add to equal 8. So let's think about it. What are some factors of 12 that would add to 8? This is a little bit of just brainstorming to come up with some possibilities and determine which one accurately solves this. So when I think of factors of 12, I think of 3 and 4, I think of 6 and 2, and I think of 12 and 1. All three of those sets of numbers satisfy our first condition, factors of c. But we need to know which one satisfies the second condition, and there's only ever going to be one of them. Which one of these sets of factors adds to equal 8? We see that right here, 6 and 2. So I'm going to go ahead and write those in here. These are my two factors, a positive 6 and a positive 2. So those are the numbers we are going to write in our binomials. Now we keep their sign. Since it is a positive 6, we are going to write plus 6. Since it's a positive 2, we are going to write plus 2. But we've finished the problem. X plus 6 times x plus 2 is the polynomial x squared plus 8x plus 12. We could check our work if we wanted. We could FOIL these two binomials and see if we get the original polynomial we started with. I'll do that real quick. FOIL. First is x squared. Outside is 2x. Inside is 6x. And last is 12. Our two middle terms combined, giving us x squared plus 8x plus 12. We did it perfect. We have the same polynomial after FOILing our two factors that we started with. That guarantees we did this process correctly. Let's do one more example before the video is over. I'll go ahead and erase what we have here. And let's say we have x squared minus 2x minus 48. This one's a little more difficult. We have some negative signs in there. Now, I may be in the minority here, but I believe whenever I see a minus sign in an expression, that automatically makes it seem like that's going to be a harder problem. Well, it might be a little more challenging, but the process is not any different. So let's go ahead and make sure this meets our criteria. Is it a trinomial? Yes. Is it a squared variable, single variable constant? Absolutely it is. And does it have an a value equal to 1? Yes. There is not a coefficient written in front of the x squared, so we're good there too. We can basic factor. So the first step is simply to write these binomials, each one starting with x, and then we just got to figure out what goes with them. We need factors of c. What's c here? Negative 48. That add to equal b. So these two factors need to add to equal negative 2. So let's think about this. If we know we need factors of negative 48, what are those factors going to look like? You may be thinking of numbers right now, 24 and 2, that kind of thing. But it's a negative 48. So one of those factors has to be negative. Exactly. Well, let's go ahead and list out those factors. We already said 24 and 2. What else? 48 and 1. 6 and 8. 12 and 4. There may be one or two more that I'm not thinking of right now, but I got a pretty good list. Let's check it so far. I need to make a negative 2. So again, we said one of these has to be negative. So let's go ahead and just glance at these and see, do we think one of them could make a negative 2 when we added it? Well, is 24 and 2 going to make a 2 by adding them or technically subtracting since one's a negative? No, that's not going to happen. 48 and 1, those are way too big of numbers. 6 and 8, now that sounds possible. Which one would be negative and which one would be positive though? Yeah, if it's a negative number when they're adding together, that means the larger one has to be negative. So therefore it must be a negative 8 and a positive 6. A really good way to identify which one of these works for you whenever you have a negative number is to identify which one of them has a difference of that number between them. If you'll notice, 6 and 8, they're only 2 numbers apart. 8 is 2 more than 6, that kind of thing. These numbers are more than 2 apart, as are these. So this must be the one that works because between them there's a difference of 2. So we said 6 and negative 8 must be our factors. 6 times negative 8 makes negative 48. And 6 plus negative 8, or 6 minus 8, gives us negative 2. So it satisfies both of our conditions. We'll go ahead and write our factors in our binomials. We have a positive 6, we have a negative 8, and we're finished right there. Now that may have felt like it took a little while, but once you do this a couple of times and you get kind of the rhythm down of solving it, you're going to be solving them very quickly. Really, this only took all this time because I'm explaining it and trying to go over it pretty slowly so that you guys can follow along and learn the process too. But I tell you, you're going to be solving these in a matter of 20-30 seconds once you get this down. So if you have any questions about basic factoring, feel free to drop them below. We'll probably do another couple example problems in another video sometime, but if you have anything you're really curious about, feel free to drop it below and I'll answer that as soon as I can. We're going to continue talking about some other factoring methods in other videos, so keep an eye out for those too. Thanks for watching, guys. See you next time.